You've tried before. You set the resolution, you made the plan, you committed, fully, completely, with absolute certainty that this time would be different. And for a few days, it worked. Maybe even a few weeks. Then one day, stress, fatigue, a familiar trigger, and you were back, doing the exact thing you swore you'd stop doing. The cigarette, the late-night scrolling, the procrastination, the sugar. And you asked yourself the same question millions of people ask every day. Why can't I just stop? Here's the answer nobody tells you. It's not about willpower, it's about neuroscience. Today, we're going to understand why your brain fights you when you try to change, and what you can actually do about it. Section 1. The habit loop. First, let's be clear about what a habit actually is. A habit is a learned action triggered automatically by a specific situation, a behavior that runs on autopilot, requiring little conscious thought. Think about tying your shoes, brushing your teeth, or driving a familiar route. You don't think about these actions, you just do them. This is incredibly useful. Habits free up your brain to think about other things while your body handles routine tasks. But here's the dark side. Habits become deeply wired over time, making them incredibly difficult to break. This autopilot system is managed by a part of your brain called the basal ganglia, an ancient region that controls motor actions, good habits, bad habits, and compulsive behaviors. Your brain builds habits using a simple three-part process called the habit loop. Cue, routine, reward. The cue triggers the behavior. The routine is the behavior itself. The reward reinforces it, making your brain want to repeat it. The more a habit loop fires, the stronger the neural pathway becomes. Over time, the connection moves from the prefrontal cortex, the brain's deliberate decision-making center, to the basal ganglia, its automatic behavior center. And once a habit is transferred to the basal ganglia, it becomes effortless. You don't have to think about it, which is exactly why it's so hard to change. Section 2. The race between go and stop. So what actually happens in your brain when you try to break a habit? Research from Duke University gives us a powerful answer. Scientists trained mice to press a lever to get a sugary treat. The mice became hooked. They developed a strong habit. Then the researchers looked at what was happening in the brains of the habit-trained mice compared to untrained mice. Here's what they found. In the basal ganglia, the habit center, there are two competing pathways. One gives a go signal, urging you to act. The other gives a stop signal, pulling you back. Think of the go signal as the devil on your shoulder. The stop signal is the angel, what we call willpower. In untrained mice, the stop signal came first. They could resist the habit because no neural shortcut had been built. In the trained mice, the default was go. Their brains told them to press the lever because they always did. The researchers found that breaking a habit meant reducing the activity of the go circuitry, allowing the stop signals to win the race. In other words, the habit isn't stronger than your willpower, it's just faster. The go signal arrives before your conscious brain even has time to engage. This is why you can be staring at your phone, scrolling social media, before you even realize you reached for it. Your brain executed the habit before your prefrontal cortex could stop it. Section 3. The surprising truth about self-control. Here's where things get interesting and deeply counterintuitive. For decades, the scientific view has been that compulsive behaviors like hand-washing, gambling, or overeating are entrenched habits that override self-control. The assumption was, if you have a bad habit, you're stuck in a loop. Your self-control is too weak to break free. New research turns this assumption completely upside down. A study from the University of Technology, Sydney, found that compulsive behaviors may actually stem from too much, albeit inappropriate, deliberate control rather than too little. Researchers induced inflammation in the striatum, a brain region involved in choosing actions, in rats. They expected the rats to become more habitual. Instead, the opposite happened. The animals became more goal-directed. They continued to adjust their behavior based on outcomes, even in situations where habits would normally take over. This suggests that some habits, especially the most stubborn ones, aren't the result of too little self-control. They're the result of misguided self-control. If someone is continually washing their hands because they're worried about germs, they're not doing this without thinking. They are consciously choosing to make that effort. The effort is there. It's just pointed in the wrong direction. This explains something crucial. Willpower alone doesn't work because willpower is part of the problem. Your prefrontal cortex, the source of willpower, fatigues under stress. When it does, your brain defaults to the strongest neural pathway. The old habit wins. This is why 43% of daily actions are performed on autopilot. Not because we're lazy, because our brains are designed to conserve energy. Section 4. The Neuroscience of Change. Now let's talk about what's happening under the hood when habits form and when they break. Habit formation takes time, anywhere from 18 to 254 days, with an average of about 66 days. The timeline depends on the complexity of the behavior and how consistently you practice. During this time, your brain is literally rewiring itself. Neural pathways are strengthening. The connection between the prefrontal cortex and the basal ganglia is shifting. A study using EEG, measuring electrical activity in the brain, tracked participants over 14 days of training. Researchers found that extensive training increased the strength of habits. People made more automatic errors when under time pressure. Stronger habits showed more action slips, incorrect automatic responses triggered by the old cue, and inappropriate habits could be detected in brain signals even when people successfully suppressed them. The researchers found that the lateralized readiness potential, a brain signal that reflects preparation for movement, could serve as a covert neural signature for habits. Even when people thought they were in control, their brains were preparing to perform the old habit. This means your brain is working against you even when you're succeeding. Every moment of resistance is a battle between two competing systems. The goal-directed system, slow, flexible, conscious. The habitual system, fast, rigid, automatic. When you try to break a habit, these two systems are in direct competition. The goal-directed system says, "Don't do this. It's bad for you." The habitual system says, "We've done this 1,000 times. It's easy, it's comfortable." And the habitual system is faster because it doesn't have to think. Section 5. The way out. So if willpower is a losing strategy, what actually works? The research is clear. You can't beat habits by fighting them head on. You have to reroute them. Here's what the science says. First, understand the habit loop. Every habit follows the same pattern: cue, routine, reward. The first step to change is identifying your specific loop. What triggers the behavior? What do you get out of it? If you can't identify the cue, you can't change the habit. Second, keep the cue, keep the reward, change the routine. According to research, a habit can be changed by keeping the cue, providing the same reward, and inserting a new routine. This is called the golden rule of habit change. If you eat junk food when you're stressed, cue stress, routine eating, reward relief, you can replace the routine with exercise. The cue and reward stay the same, the behavior changes. Third, weaken the go signal. The Duke University study found that breaking habits required reducing the activity of the go circuitry. This means consciously stopping the task for a while so the go signal isn't reinforced. With time, it weakens. This is why time and repetition are essential. You can't break a habit in a day because you can't weaken a neural pathway in a day. Fourth, stop using willpower alone. The prefrontal cortex fatigues under stress. When it does, your brain defaults to the strongest neural pathway. Instead of relying on willpower, restructure your environment. Remove the cue so the old routine never fires. Practice the new behavior repeatedly. Repetition strengthens the new pathway until it becomes default. And address the underlying beliefs. Every persistent habit is sustained by a thought pattern that justifies it. Fifth, be patient, really patient. Habit formation takes an average of 66 days, not 21, not 30, but 66. Complex habits take even longer. The habit isn't stronger than you, it's just older. Your brain built those neural pathways over years of repetition. It didn't create them to hurt you, it created them to help you survive, to conserve energy, to automate routine tasks, to free your mind for more important things. But now those same pathways are keeping you stuck. And that's okay, because understanding them is the first step to changing them. You're not broken, you're not lazy, you don't have weak willpower. You're just fighting a system that's been running since before you were born. The good news? That system is plastic. It can be rewired, one step at a time, one day at a time. You already know what the first one is. I'll see you in the next one.